So today we're going to take a look at how to find perimeter of composite shapes. And perimeter is something that we've learned probably in elementary school quite a bit, which is great. But we're going to expand it to bigger ideas. So perimeter means distance around the outside. All right. And composite shapes means they're irregular. All right. So that's what we're going to look at. So we're looking to find perimeter of a figure. I'm learning that perimeter is a distance measurement. It's always contained units with the answer. So common units could be centimeters, meters, kilometers, inches, feet. All right, it's a linear measurement. All right, so we know that that's the distance around the outside. All right, so in this course we'll find the perimeter of shape by highlighting the outer edge. So why is it a good idea to highlight? That's a really good question. Well, highlighting the outer edge, all right, it allows us to have a visual of what we're finding. All right, so if I'm looking at this, if I'm highlighting the outer edge of the shape, I know exactly what I'm trying to find. Okay, so one of the funnier things that we're going to look at is perimeter of circle. Sometimes it's called the circumference. Okay, and the circumference is basically the distance around the outside of the circle. Okay, and there are two formulas for that. One is c equals pi times the diameter, or another one is 2 pi r. So the r is the radius and the d is the diameter, and both will work. Okay, so that might be the only formula that you have to write down. Keep that in mind. So when we find the perimeter of a shape, it's a good idea to figure out, do I know all the sides? So a question you ask yourself, do I know all the exterior lengths / sides? All right, if I don't, I got to solve it. All right, and sometimes we might have to infer some of the things. For example, I have my rectangle here. I know majority of people would say, hey, you know what? That side has to be 3.7. That side has to be 2.8. So write it down. Make it visible. All right? And then when I'm finding the perimeter, and then I can add up the sides. All right? So make the learning visible. And then if I add those sides up, 3.7 plus 2.8 plus 3.7 plus 2.8, I know that is that. So when I show my work, that's what I'm looking at. Now, here's my circle. Well, we know the perimeter of a circle is, and I'm going to have to use, I have to use my stylus for this, pi times d. So in this case, my radius is 8 centimeters. So that means it's got to be 16 centimeters through the middle to the sides. And when I'm looking at that, some people like using 3.14. but see if you can find the button on your calculator. So if you look on the calculator, you can use the pi button on the calculator, and it will look like that. You might have to push shift and hit pi. But basically, if you're able to do it, all right, so that means it's just over 50 centimeters around the outside of that circle. Okay, so when we show our work for a perimeter question, especially with its full solutions, put P equals, so start it like an equation. Only distance around the outside of the figure is calculated. So what we're looking at here is we're only looking for the distance around the outside of the circle. Maybe there's parts of it where it's a half circle, or maybe there's lines on inside this rectangle, whatever. That doesn't account. We want to know if we were going to put a fence around the outside of that shape, we want to know that distance. We're going to find missing sides on the side. We'll do some side work maybe. All right. And we can put an approximate side if it's not an exact unit, and that's okay. All right, so let's give this a go. So if I'm looking at this shape, you might ask yourself, okay, the perimeter. Well, when people do the perimeter of the shape, sometimes they do, okay, 3.5 plus 2.5 plus 2.1 plus 1.5. Well, is that right? I hope not, because is the 1.5 on the outside of the shape? No. So I don't want that part to be there. So you want to always ask yourself, is the distance around the outside, is it on the outside of the shape? All right. So you want to be able to understand that when adding things up, all right, do I get that? Okay. So let's look at this now. So I have, well, what do I have? I guess that's a really good question. What do I have of the shape? Well, I've got two sides that are 5 centimeters along, okay? But I have a half circle. All right. So if I'm finding the circumference of a half circle, all right, you probably guess it. I want to divide it by 2 because I want half of it. Perfect. All right. So I'm going to have to go and find that. So pi times 10, because it's 10 centimeters along, divided by 2. All right. So 3.14 times 10 divided by 2. I've got 15.7 centimeters, approximately. And now I can find the perimeter. So I know that the perimeter is 15.7 plus the 10 centimeters along the bottom, because that is on the outside of that shape. So 25.7 centimeters is the distance. So just be conscious of what's on the outside of the shape. All right. What do I have here? Well, I have a right triangle. Well, do I know all my sides? Well, no. So guess what? I think I might have to use Pythagorean theorem to find that missing side. So when we did that yesterday, or the last lesson, we say, well, where's the hypotenuse? Well, there's the hypotenuse because it's across from right angle. We need to have those two as well. So we know that that is that. Okay. And then I sub in what I know. All right. C, do I know C? Yeah, it's 16 because I labeled my triangle. That's 9 squared plus b squared. Okay. So I'm going to actually pause it here because I want to see if you guys can check your work to see if you remember how to do it from the previous lesson. So hopefully you've checked it. All right, I squared each term. I had to move the 81 away from b because that's what we're solving for. All right, and then I had to do the square root. All right, to get that. But have I answered my question? No, because I need to find the perimeter. Well, so my perimeter, well, I know it's 9.0 plus 16.0 plus 13.2. And I can add that up. 9 plus 16 plus 13.2, 38.2 centimeters. So maybe I have to do some small steps to get to the actual perimeter. All right, I had to find that this bottom side. Moving forward. All right, so sometimes we have these regular shapes. Well, one of the thinking that we have to worry about here, all right, definitely you want to find all missing sides. Okay, so when you're doing that is make it visible on the shape. All right, so don't try to find the missing side right away, or find the missing side as you're adding up the sides. So, for example, I have, and I'm going to use my highlighter here just to kind of prove a point. All right, so I've got this side, I've got this side, nope, nope, I got that side, and I've got that side. So if I look at this, all right, oh, I don't like that. I don't know those two sides, but I can use some logic. I might have to use some logic to figure that out. So if I look at this, well, that side right there, well, we know 18 is already been used, or 18 is used there. 10 of it is on this side. So that missing side has to be 8 centimeters. So I'm going to put 8 centimeters here. And then I'm going to move my thinking out a little bit farther. So this has to be 8 centimeters here. And my thinking, the reason why it's the 18 minus the 10, that's where I used. All right. So what I want you to do is use some logic to figure out what is the missing side here. And I'm going to push pause and you guys figure it out. So hopefully you said it was 14 centimeters because we've used 20, we have 28 to start, and I've used 8 of it here to get that 14 centimeters. So that's the logic part, and then I made it visible. All right, now I can go to this and say, now I know my perimeter. So 22 plus 18 plus 8 plus 8 plus 14 plus 10. All right, so make sure that when you add up the sides, you're adding up every single side that you have there. 22 plus 18 plus 8 plus 8 plus 14 plus 10. I've got 80 centimeters. There we go. Perfect. So my side work is all done on the side. I have to do some logic. All right, so let's look at another one here. Kind of like a trapezoid, but let's see what we could come up with. Well, what do we know? Well, we know that that is 15. We know that is 30, and that's all we know right now. Well, the question now is, what is that, and what is that? Well, to start with, we might be able to say to ourselves, well, I've got this funky dash there. Those mean that they're equal sides. So therefore, that has to be 15 centimeters. Okay, that makes sense. Well, the question now is, what about this slant? Well, anytime you have a slant, Pythagorean theorem comes into play. Okay, so what we need is a right angle triangle. Well, so let's put a right angle triangle in here. Okay, so if I look at this, that is 15 there. And this side, 30's been used, and 15 has been used there. So that's going to be 15 as well. All right, so actually I'm going to push pause now. I want you to find that blue strip there and come back and we'll take a look at it. So hopefully when you did that, you wrote down the Pythagorean theorem, but you should identify the hypotenuse. Well, that should be the hypotenuse side because it's across from the right angle. All right, and this could be A and B, and then I can slip that in, square both sides, and add those up, and then take the square root. All right, so we've now found that side to be 21.2 centimeters. All right, so I'm going to push pause here, and I want you to go find the perimeter. So I added up the four sides that I have. Now, when doing this, it's probably going to be important to figure out, okay, what are the sides that I'm using? Well, I want to use this side, this side, this side, and this side. So this 15 and this 15 is not really part of my perimeter. It's just the 30, the 20, the 30, the 15, the 15, and the 21.2. All right, so be careful that when you find some missing information, you don't include it into the perimeter. And that's where people miss out with some logic. All right. All right. Sometimes they ask us to go backwards. Well, what do you mean by backwards, Mr. Brzee? Well, the idea here is sometimes they give you the perimeter and you have to find a side. Well, we know how to solve equations. We have the tool to be able to solve equations. All right, so let's use the tool. All right, so if I'm a plumber, I'm not going to be using an adjustable wrench. I'm going to use a plumber's wrench to do what I have to do. Use the proper tool. All right, so the question is, what do we know? Well, I've got kind of like a rectangle here and this little hump. Well, if I look at it, if I draw across that, oh, I've got a half circle. Okay, so we might ask ourselves, okay, with our half circle, our diameter is 240 centimeters. So we know if we're doing a half circle, I'm going to divide it by 2 because divided by 2 is taking half. All right, so I'm going to figure that out. So pi times 240 divided by 2. So that is basically 377 centimeters. Pretty close. 377 centimeters. So we know from what that piece of information is, we know this piece and we know this piece. So the question now is, if we were using the perimeter is 967, all right, and we're solving for x, well, there's my x. Well, my question to you is, what does this other side have to be? Hopefully you said that has to be x as well. because it looks like it's going up, straight up. All right. So when I make my equation for perimeter, all right, so my equation for perimeter, it looks just kind of the same way. All right. So I'm going to do like a general statement, sum of sides. All right. But we know the perimeter. The perimeter at the start was 967. Oh, that's good. 377 plus x plus 240 plus another x. Well, now we know how to solve equations. So what we can do is, when we solve equations, we collect like terms. And use inverse operations. All right, well, let's collect our like terms. X and x become 2x. My 377 and 240, that is 617. And that falls down there. Now I can use my inverse operations. All right, so now I can subtract 617 from both sides. So I can take 967 minus 617. So I've got 350 on the left side. That is 0. So now I'm left with 2x here. All right, now I can divide by 2. There you go. So justifying my reasoning, figure out the half circle, making up an equation. Okay. So we're using logic, we're using our tools solving equations to figure out solutions to problems. All right. All right, last question, and then we'll set you on your way. Getting tracking. Ashley runs around the following track. How many times must she run around the track in order to run a total distance of 4 kilometers? Show your work. So 1 kilometer is equal to 1,000 meters. So we might have to use that hint. Okay. So I'm running around the track. So this is perimeter. All right. Run around the track. All right. Because in the future, we're going to be able to mix up perimeter and area. Okay. So the question is, let's figure out what the perimeter is. All right. So I've got 100 meters. If I look straight across, that's going to be 100 meters. All right. 60 meters is there to there. This is going to be 60 meters as well. So the question now is, how many times, well, what's the perimeter of the track? Well, what do we have? Well, we actually have 2 sides of 100, and I got 2 half circles. Well, my logic says that's got to be 1 whole circle. All right, that we're going to find the circumference of. All right, so we know that the circumference of the circle is pi times d, and we know our d is 60 meters, because that's what we were given in the question. So on my calculator, I can go pi times 60. That's approximately 188.4 centimeters. Now, if you thought of it differently, if I split that into two half circles, this would be 94 meters here, 94 meters here. Okay. Now we can find the perimeter of the track. Okay. So I've got 94.2 plus 100 plus 94.2 plus 100. So that's going to be 388.4 meters. All right. So it's not quite 400 meters, which would be a full track, but yeah, we'll live with it. So how many times must you run around the track in order to run a distance of 4 kilometers? Well, what that's saying here is this is actually called a proportion. Well, we've dealt with proportion from our previous learning. All right, so I can say compare the distance to the laps. All right, well, what we know here is we know that this is 1 lap of that track, 388.4. Well, we want to know the distance, 4 kilometers. Well, 4 kilometers is equal to 4,000 meters. All right, so we can put that into there. Now we can solve for x. And if you remember going back to some of the learning, if x is on the bottom, we flip both fractions. And then we can cross multiply. So we know that 400, or 4,000, my fault, is equal to 388.4 times x. And then we can divide both sides. All right, and you can probably take a guess what that answer is going to be. I was thinking around 10. It's just a little bit more. So I've got about 10.3. All right, so the question there is, how many times must you run around the track in order to run a distance? All right, well, we'll have to run 10.3 laps to run a total of 4 kilometers, which means 4,000 meters. There you go. So hopefully that's helped as you're moving forward with learning this. Okay? But there's a common theme throughout this. All right? And the common theme is, and I'm going to go to the next page. The common theme is, start off with the equation with P. Only the distance around the outside is calculated. So you're only adding up the outsides. Missing sides are found using appropriate strategies. So your strategies could be Pythagorean theorem. Maybe it's half a circle, those types of things. All right. So give the work a go, but these are kind of the steps that you should be showing moving forward.